guys, we're back. This is the quadratics unit, and we're going to bring back an old topic today with factoring, and then we're going to use the skill of factoring so we can actually solve quadratic equations. So this is probably the most readily used quadratic solving method. We're going to learn a whole bunch of methods, and as much as you think you like or don't like factoring, it is going to be your go-to reaction when given a quadratic, is you're just going to assume you can factor it. So that's good news. We're going to get a lot of practice on factoring today. So that's our warm-up first. We're going to think about our factoring flowchart, and remember that the top of the flowchart said always to look for any common factors that you could take out first. So let's do that. If I look through number 1, common factors can be numbers, could also be variables. So I'm noticing a 5 and an x in common between these two terms. So factoring out the common term looks a whole lot like dividing. So if we were going to then take a 5x and divide into each term, what do we have left here? We still have an x. We're going to undistribute, right? We called that undistributing before. And then a minus 6. That's all we're doing in this warm-up. We're just factoring them. So similarly here on number 2, I'm going to look for a common factor, and I actually don't have a common factor on this problem. So then as I move down the flowchart, it's separated into how many terms do you have? So if we had 2 terms, then we possibly used a pattern that was called the difference of 2 squares. And the way the difference of 2 squares worked was if it followed this pattern where it was something squared minus something squared. Then it factored into good twin a plus b times evil twin a minus b. And that's exactly what we see here. So if you were to square root each of these terms, that would then factor into, and be careful on this first one, the square root of 4x squared would be a 2x and a 2x. Remember, we're looking for twins. And then the square root of 81 would be a 9. So we're going to have a plus 9 and a minus 9. And that's what the factoring looked like on number 2. So then we hit something like number 3, where there was no common factor. 2, 15, and 7 don't have a common factor. There's 3 terms this time. So we're going to use that reverse spoiling technique, where you kind of guess and check your way through the problem. So hopefully you have enough practice where you don't have to make too many guesses, and this first term isn't really anything other than a single guess because it's a prime number. So what times what gives us 2x squared? That has to be a 2x times a 1x. And then we go to the outside term, the last term, and again we have a prime number, so that's good news. There's only one way to get a 7, and that would be a 7 times a 1. Where I place the 7 and the 1 makes the difference. So I'm kind of going to look ahead in this problem and remember that I want to add up to a 15. So what if we put the 7 here and the 1 here? This is where we have to check our arches. This arch is a 1x, and then this arch is a 14x. And surely, if we add those together, we get 15x, which is what we wanted in the middle. And I kind of jumped ahead with using plus signs in that factoring problem because everything was a plus. So that should be a good warm-up for you for how to factor. If that's where you're going to get stuck today is, man, I just don't feel comfortable factoring, then we just have to go back and practice factoring. Because today we have to now solve an equation through factoring. It actually isn't very much more difficult than what we just did. Factoring is probably the hardest part of the questions today. So let's think about this. Once I turn this into an equation, that means I set it equal to something. So think about this theory problem in math. If you have 2 things being multiplied together and their product is a 0, what do you know has to be true? Well, the only way for a product to come out to a 0 is if one or both of the numbers are 0. So that's what factoring is. That's why we're using it. We're taking what would be an addition problem, we're factoring it into a multiplication problem, and now we can set those equal to 0 because that's a mathematical law. If you have a multiplication problem that equals 0, the things, the multipliers, have to be, one of them has to be 0. So our first step in these questions is to make sure that it sets equal to 0. So if your equation doesn't say equals 0 on one side, you got to move terms around. Your second step would be to factor. And that's really the major step, right? And then our third step is to set the factors equal to 0 and solve. All right, I'll show you what that looks like. So step 1, it's already set equal to 0. Step 2, factor. Well, there's no common factors, and it is a trinomial. So we're going to do that guess and check thing. Why am I using the wrong color? We're going to do that guess and check thing, but this one doesn't take a whole lot of guessing. So at the beginning of my trinomial, what times what gives me x squared? That has to be an x and an x. And then at the end of my trinomial, something times something gives me negative 40. And then look ahead in your problem. You want your arches to add up to positive 3. So wouldn't it be smart if we did a plus 8 and a minus 5? Because those would multiply to negative 40 and the arches would still add up to positive 3. You should check your arches. I know a lot of you are checking your arches in your head at this point, which is awesome as long as you're doing it correctly. Okay, so now that I know I checked my arches and I'm doing well, now that I know I have the right factors, now I can set my factors equal to 0. So this and this, these are each factors. So we're going to take the x plus 8, and we're going to say it could be 0. And then we're going to take the x minus 5, and we're going to say, but it could be 0. And we're going to solve these two linear equations. So like right here, we would subtract 8 over, and we get x equals negative 8. And then right here, we're going to get x equals positive 5. So you might be asking yourself, like, well, which one's right? And the answer is they're both right. So unless it's an application, you're going to typically get 2 answers on a quadratic, and they're both good answers. So be forewarned on that one, huh? Now, I know what some of you are thinking. You're like, I just took the opposite. Ooh. Okay, it's not as simple as just take the opposite in a lot of cases. So I want you to really think about what happened is you took the factor, which is a linear equation, and you solved it, is what you did. So this next question, it is set equal to 0, so step 1 is done. Now let's talk about how we're going to factor this. Well, there's no common factor. And because it's got 2 terms, we're going to use that difference of squares pattern again, the one where you have a good twin and an evil twin. That's not the official name, right, by the way. So if you were to square root each of these terms, we would get, think about what happens here, guys. This is a 4x times a 4x, and then a 5 and a 5, where one is a positive and one is a negative. So that was the factorization step. And now that you have these factors that are multiplied together, for this to come out to 0, one of these factors has to be 0. So you're going to take your turn, setting each of them equal to 0. You're going to say 4x plus 5 could be 0, or 4x minus 5 could be 0. And then you're going to solve. Now this is why I was cautious for my friends out in the world who are like, just take the opposites. This is a 2-step linear equation to solve. You're going to start by subtracting 5 over, right? But then you're going to divide by 4. And I know you guys are probably capable of doing those steps in your head, but like on a quiz or on homework, on practice, it's not worth it because if you make a mistake, it's too hard to follow. All right, same thing here. So you're going to add the 5 over and then divide by 4 again. So this time it's a positive 5/4. And those are the type of answers you're going to get each time when you have this good twin, evil twin, this conjugate pattern is what it's called. You're going to basically get a positive answer and a negative twin of that answer. So it's nice to know when you should get what you're expecting to get in math. Number 6, already set equal to 0. So I'm going to try to factor this, and I think about my steps for factoring. The first thing I look for is a common factor. So a common factor here would be a 2 and an x. And this is where it gets a little confusing because a lot of kids are thinking, oh, I'm just going to divide 2x over. You can divide by the 2, but what you can't divide by is the x. If you divide by a variable, you're actually losing a whole set of equation solutions. So instead of dividing it, I'm just going to leave it out in front like we always have. So if I factored it out, I still have an x plus a 9. And then it still says equals 0, which I didn't make a big note about this at the beginning, but it did say equals 0 at the beginning. So here, this is where kids get confused because they're like, wait a minute, what do I do with this? This is a factor, right? Factors are 2, in this case, 2 things that are being multiplied together. So if you were to set this factor equal to 0 and then this factor equal to 0, this is what your work looks like. 2x could be 0, or x plus 9 could be 0. And then we just solve. So dividing 2 on both sides. This is why the kids who divided by 2 but left the x are still getting the right answer. You're still going to get x equals 0. The important thing is that you didn't lose that solution because you divided the x by accident. And then here you're going to subtract 9 from both sides. And you got x equals negative 9. So again, quadratics, typically 2 answers. And we just got 2 answers. All right, and then number 7 has a more challenging factoring question. There's not a common factor this time. So I do have to kind of guess and test and revise my way through this, but perseverance is key. If you don't factor this right and then you go to solve it, your whole problem's garbage because you don't have the right factors. So what times what will give me 3x squared? That's going to have to be a 3x and a 1x. And then at the end of the problem, I want my products at the end to multiply to a positive 4. So I know I need the same sign. And if I look ahead in my arches, I need the arches to add up to negative 8. So that tells me I'm going to need a negative and a negative. And I'm not going to put a 4 here because that would be a 12. That's too big. And I wouldn't put it here either because that would be a 7. So the only other option for 4 would be a 2 and a 2. Let's check the arches, double check that it works out right. This arch is a negative 2. And then this arch is a negative 6, which those totally do add to negative 8, which is what we needed. So now you're going to take each of your factors and set those equal to 0. So I think you get my point here. The factoring is probably the only really, truly tricky part about today. And those of you who are uncomfortable factoring, you're probably uncomfortable today. This is one of those magic moments in math where things build. And if you're not with us, then you're not feeling good. So I don't have good advice other than to go back and practice basic factoring a little bit more. All right, so x equals 2/3 is one solution. Get out of the way, face. And then over here, much easier to solve, right? X equals 2. There's the other solution. All right, couple more. What was rule number 1? It had to say equals 0, right? So this question definitely does not say equals 0 anywhere around here. So we're going to move all of our terms around so that one side of the equation says equals 0. I'm going to choose to move everything to the left. So I'm going to subtract this x squared to the other side. And I'm also going to subtract this 2 to the other side. And when I say the other side, I mean of the equation. I just wrote that really dumb. I'm sorry. Oops. My negative's like not even in the right spot. Okay, so my new equation is, oh, this is nice. This became a much nicer quadratic. X squared minus 3x and then a minus 10 equals 0. Now I can go through and factor it. No common factor this time. Just a little guess and check reverse foiling question. But a much nicer one, so that's awesome. What times what is x squared? Well, that's x and x. And then multiplies to negative 10, but look ahead in your problem. You want your arches to add up to negative 3. So how about we do a minus 5 and a plus 2? And just kind of double check in the arches. That's a negative 5 and that's a plus 2. And yes, those do add up. Plus 2. Those do add up to negative 3. So now that I know I have the right factors, I can set each of my factors equal to 0. My face is in the way again. All right. So the first factor, x plus 5 could be 0, and then the other factor says x plus 2 could be 0. So solving, adding 5 to both sides, you get x equals 5 for one solution, and then here you're going to subtract 2, x equals negative 2 for the other solution. Same idea on number 9, it's not set up for factoring yet, so you're going to need to move this term over by adding the 12x, and I'm going to sneak it in right in between these two terms so that way it's in standard form. Okay, at first glance, this problem looks like a real doozy because there's no common factor and then I got coefficients everywhere that are going to mess me up. But one thing I do notice about this question is that the beginning and ending terms are both perfect squares. And when that happens, usually that's a dead giveaway that you have one of those squared patterns. So you want to use the factors that are your perfect square, like the twin factors. So even though 4 has a couple of options, I'm leaning towards 2 and 2. And then same idea with the 9. Even though 9 has a couple of options, I'm leaning towards 3 and 3. And of course, I want to double check the arches to make sure that they add up to positive 12. So that's a 6x in the middle with another 6x, which is totally 12. All right, so now, and this is an interesting case, when I set my factors equal to 0, they're the same factor. So that means if I were to solve them each, I would get the same solution twice. I don't have to solve them twice. I just need to write it once. We're going to learn later on in this class that what's happening here is you get one solution twice called multiplicity, and when we look at the graph of this, the parabola actually bounces off at this particular value that we're about to find. So I'm going to solve. And I get 2x equals -3. One final step here. I wrote too big. All right. So x equals, you can say -1.5. I'm going to say -3/2. But you would be equivalent if you wrote something else. All right. I think that was the last question, wasn't it? Oh no, there's one more. We actually saw this question on the quadratic modeling. It was a different question, but the same idea. And you could, if you didn't have a graphing calculator and didn't want to guess and check your way to the right answer, or the answers weren't coming out nice, you could try one of your algebraic methods for solving a quadratic. So in this case, it would be a factoring problem. The area of a rectangle is found by, length times width, and it equals 36 square feet. So if I multiplied these together for area, it would look like this. X times x minus 9 is 36. Now, be careful. They want the perimeter at the end of this question. This is a bit of a trick question, and I've seen this on standardized testing before, so be very careful. We're going to go ahead and try to solve this through factoring since we've been factoring. And the reason I'm distributing the x is because number 1 says your quadratic has to say equals 0 on one side, and we don't have that. So I'm going to distribute, and we're going to get x squared minus 9x equals 36, and now I'm going to subtract that 36 over. So I'm sure you've noticed today in almost every example when we've solved these quadratics, we've gotten 2 answers. And I kept saying, like, they're both correct. They're both correct. My little caveat was, unless it's an application question. This is what I'm talking about, okay? So what times what gives you x squared? Clearly that's x and x. At the end of the problem, I want my my product to be -36, but I want my arches to add up to -9. So after a little bit of thinking about that, I'm thinking -12 and +3. I should be checking my arches, but my voice is getting scratchy and I need to stop talking. Okay, so they work. They totally work. My 2 solutions, though, that I get here would be x equals 12 and x equals -3. So can you have a rectangle that has a dimension of -3 feet? And the answer is nah. So this is just a goofy answer. It's extraneous is actually what the word we use in math. This is the only viable answer. So x equals 12 is great. I know that this is a 12. And if I plug in a 12 here, that means this side is a 3. So the perimeter, be careful, don't be confused here. The perimeter is 12 plus 12 plus 3 plus 3. So that was at 30 feet. Tricky, tricky, tricky. A lot of kids, if this was an ACT or an SAT question, they would get down to x equals 12, and that would be a choice because they're kind of jerks like that. And then later on in the choices, they would have 30 feet. So, nice. All right, that should be our last question, I believe. Oh, yeah. All right, so practice, practice. If the issue is you're still having trouble with factoring, that's a separate issue, and we can work on that together, All right, good luck, everybody.